Hi everyone, and welcome to my ENME 351 final project. Let's go. So the idea is pretty basic. We're gonna have a distance sensor here that's gonna measure the distance to this box between 3 and 24 centimeters. Then we have a stepper motor here that's basically gonna track an angle. So if it moves forward, the stepper motor moves to the left and vice versa. So it follows it really nicely. It's updating pretty frequently. And then up on our processing screen, we have the ENME 351 meter. That's gonna follow that angle with that needle as well. See that needle move? There's the needle. Let's move it again. Let's do about to the center. You can see it's about to the center in that yellow zone. The hardest thing about this project was knowing exactly where the stepper motor was. From our stepper motor lab, I could easily move it 90 degrees to the right or 90 degrees to the left, but finding a starting position and thus everything else was difficult. That's where this distance sensor come in. So what I did was I moved the stepper motor very slowly in the clockwise direction until this distance sensor encountered it. Then we knew our starting position, and from there, everything worked. Everything is done inside of the shoebox. The stepper motor is attached to an H-bridge over here. The wiring gets pretty complicated. This H-bridge wiring was actually pretty much identical to that we did in the stepper motor lab. And then the distance sensors were pretty basic. I found some online resources on the Arduino website that helped me wire those. Looking at our Arduino code here, we have 4 very important functions: get, distance, clockwise spin, counterclockwise spin, and go to angle. Here in our setup, that's how we found our initial starting position for the stepper motor. We say while distance 2 is greater than or equal to 10, that's our threshold. We're gonna spin the motor slowly, that's our counterclock spin, and delay 200 each time, give it the distance sensor time to react. And then we're gonna continually update our distance sensor until that value is less than 10, which means we found our starting position. I know I said clockwise when I was showing it originally. The counterclockwise and clockwise functions are switched in terms of coding because when I coded it, I built it looking from the other side. Our loop is pretty simple. We're just gonna find distance 1, which corresponds to this distance sensor. We're gonna map that distance to a target angle using the map function. And then we're gonna call go to angle on this target and current angle, and then we're gonna update our current angle. The loop updates pretty often and it practically seems simultaneous. Go to angle is pretty simple. It takes the difference between the target and the current angle, decides whether we wanna spin counterclockwise or clockwise, and then does that. Clockwise and counterclockwise spin, we're taken directly from the stepper motor lab. Pretty simple functions there. And then the only other function, get distance, this is where I got code from online. You can see a link here. It'll be in my submission. I just put that code into a function to make things easier. Processing code here. So I made a function called draw meter so it would be easier to update the screen. We have our black and white arc, our red section, our yellow section, our green section, and then our semicircle by the needle. Setup was just establishing the serial ports and then inserting our font that says ENME 351 meter. Then inside our draw function, we're just gonna draw, find our data from the serial port, read our angle, convert it to radians, make sure that angle is between 0 and pi, and then map that. You can see X and Y are mapped to actual coordinates from that angle. And then our line and stroke weight is gonna draw the actual needle on the meter. One thing to see here is I added this correction factor, that's what I called it, of 1.6. That's just because of the stepper motor. It was acting a little funky. I basically found that the angles the stepper motor was trying to turn were about this much off from what I actually wanted them to turn. Now let's watch an action from start to finish. So here we're trying to find our 0 position. The stepper motor is slowly moving clockwise until this distance sensor finds it. Now we've moved into the correct position. Our ENME 351 meter reflects that. Let's move it again. ENME 351 meter reflects that. Just going over the project requirements, of course, we have our distance sensors as input, our actuator in the terms of our stepper motor, and then our processing, and of course, our Arduino code. I originally actually wanted to use a ping pong ball, but the distance sensor has a really hard time picking up the ping pong ball after a certain distance. So this random box actually works a lot better. And it's just tracking the movement. All right, guys, that's it for my final project video. I had a blast making it. I hope you had a blast watching. And that's it for ENME 351 videos this semester. Thanks again.